Ladies and gentlemen, a very good Saturday to you all, wherever you may be tuning in from. I hope you can hear me. If you can't hear me or if you're facing any technical difficulties with this masterclass, either at this point in time or throughout the course of this webinar today, leave a comment in the comment section, and then we'll do our best to see whether it's a problem on our end and you need troubleshooting, or whether or not we can help you out with that problem on your end. Now, how are all of you all doing today? I know we're all glad to put 2020 behind us, but the fight against COVID-19 is still not over. And I do hope you guys are staying safe and taking care of yourselves no matter the situation in wherever you may be. We will get through this, so believe in that. It's 1:30 p.m. and very sunny out here in Singapore today, but the proliferation of technology and the COVID-19 enforced border closure means that events like this webinar are not only possible to engage a large number of people, but it's also now accessible to anyone, anywhere. I know we've got attendees from Asia and beyond, so a very good morning to those of you who are not in the same time zone as Asia. From the last count, we've got people coming in from as far as Nigeria and Namibia out in Africa. So for those of you who are in that time zone, about 6 hours behind, a very, very good morning to you. My name is Terence Ong, and I'm with the National University of Singapore, or NUS for short. I am also your host for today's Masterclass in Data Science, which is brought to you by the NUS Master of Science in Industry 4.0 Graduate Degree Program. This is the first Masterclass we're doing in relation to this multidisciplinary degree program, and we hope this may be the first of many more. Now, before we get this show on the road, I'd like to give a shout out to all of you out there who took valuable time or sleep out of your weekend to be here with us. Show us your love and let us know in the comment section where you are tuning in from. Well, we know that there are quite a few Singaporeans who are tuning into the show, so show us some love, Singaporeans. If you're outside of Singapore, in Southeast Asia or wider Asia, or even Europe or Africa, as I mentioned earlier, leave us a comment and tell us where you're tuning in from. All right. I see people tuning in from Vietnam, India, Malaysia. Minho, hello to you too. I see Dan chiming in from Greece. I see only the short form of your name, Dan. So hopefully it's okay for me to call you that. Malavika from India, Hui from Singapore, Daniel from Vietnam, and I think the list goes on. And so from Bukit Timah. I'm not that far away from Bukit Timah, so shout out to my homie over there. Singapore, India. Joseph tuning in from London. Joseph, a very good morning to you. Fidela from Indonesia. Vinicio from Guatemala out in Latin America. Queen, who's tuning in Japan right now, and see a lot of Indonesia, Greater Singapore, Subian. Well done. Victor from Hong Kong, I see you too. Rachana, Thailand, see you too, welcome. Julio from Honduras, I see you too. Very, very good morning to you. Thanks for, taking up some time in this morning to join us today. And I think we pretty much covered most of the country so far. Franklin from mainland China, I see you. Julio, I see you as well again. And Kai, finally, from Malaysia. Ladies and gentlemen, I just want to say thank you so much for taking out time from your valuable weekend to be with us today. I promise you, you are going to be in for a very informative and exciting ride for today. Now, before I get the show on the road, I just want to explain to you what we're going to do here. We're going to kick things off with the masterclass proper in a bit. That would then be followed by a Q&A segment where we will answer all your questions under the sun. Well, the sun that covers today's masterclass at least. You can leave your questions for the NUS team in the comments section throughout the course of today. And as we speak, the NUS Backstage team is already monitoring the section and ready to pluck out questions that we can feature and tackle later on. There is no need to wait till the Q&A segment proper to lock your questions in. So get them in as soon as you think of them, because if you forget about it, you may not get an answer from us today. Now, today's masterclass will be held by Associate Professor Carol Hargreaves. Professor Hargreaves is an analytics and business intelligence professional with over 30 years of experience in the field of analytics. She is currently the director of the Data Analytics Consulting Center here at the National University of Singapore and is also part of the teaching faculty for the NUS Master of Science in Industry 4.0 graduate degree program. There, she supervises capstone projects related to data science. Prior to this, the South African native has held various leading roles in the pharmaceutical, healthcare, fast-moving consumer goods, and education industries. Over the course of her career, she has helped renowned corporations like Pfizer, Nestle, and Foxtel, to name a few, become more data intelligent. Fueled by an ever-burning passion for solving business problems with data-driven solutions derived from analytics and machine learning techniques, Professor Hargreaves has built several data-driven systems that make business process more efficient, thus keeping customers engaged and satisfied while ensuring organic revenue growth. It is my pleasure to invite Professor Hargreaves onto the virtual stage now. Professor Hargreaves, please.
Thank you, Terence, for that kind introduction. And good afternoon, everyone, and welcome to my masterclass on data science. Allow me to share my screen. Okay, the way in which I'm going to run the masterclass is firstly to look at what is Industry 4.0 and how does data science feature in it. I will next look at how does data science help businesses attract more consumers, followed by some examples of data science applications in real life. And I will conclude with the data science capstone projects that I've supervised in the NUS MSc Industry 4.0 module. Okay, so just to set the background to my presentation is to understand that the advancement of technology has evolved drastically. We are all deriving and generating data through social media, through online buying, as well as through point of sale in the normal motor buying of products. So the thing is that this data comes down in lots of volume. Besides it being big data, it's big data in the sense that the speed of the data that goes from our mobile phone is extremely fast. And the third point about our evolution at the moment is that the data is also from a variety of sources. So this variety of the data, the speed of data, this large volume of data has changed the way in which we can analyze our data. A few years back, we could use data and analyze it through Excel sheets or using relational database management systems, SQL. But today, a lot of the data, because of the variety of the data, because of the format of the data, we need to move towards new technologies where these technologies can handle that variety of data. Because the aim is that we need to have a 360-degree view of our customers, of all our products, and of all our transactions. And only when we have that 360-degree view can we make holistic solutions, and in that way our solutions will be more accurate than only focusing on data as we know it. So big data analytics is now playing a critical role in Industry 4.0. So you may have heard this term Industry 4.0 quite frequently in this last year, but what is Industry 4.0? Well, it consists of, in my view, 10 components. Just to mention a few, of course, big data and analytics. It consists of autonomous robots. It consists of cybersecurity. Cloud computing today is a given because the data is so huge, and also because we need the data to reach our analysis with a high speed. And that's how the cloud computing is able to do that. It's able to process our data as fast as lightning in a sense that it can analyze the data in real time. And is there a need for that? Yes, of course. Because potentially customers may be walking past the business, and in order to incentivize them to come inside the business, we need the processes to be able to identify firstly that there's a customer there outside nearby our business, and secondly, we need the right promotion to offer the customer in order to incentivize them to come into our shop and buy. So let me give you, I guess, a little bit more detail on some of the components of Industry 4.0. So to refresh, data is everywhere. It's collected all the time from sensors, from social media, e-commerce platforms, mobile devices, etc. So with that, we need to be able to process that data, because having all that data does not mean anything. We need to derive insights in order to take action, in order to make decisions. Having all the data does not do it. So with the big data and analytics, this technology helps us to derive the insights faster and smarter. Smarter in the sense that it's using consistent factors and it's learning consistently, which means that the algorithms are improving over time, which means that the decision-making is accurate at all times. So besides data, I mentioned earlier that today we have all sorts of data and mostly unstructured data, so different to previously. And that means that we need newer technologies. And one of the technologies that easily can ingest this unstructured data is your cloud computing, where it is also able to take non-relational database systems and it's able to keep all types of data and allow them to integrate and speak to each other, which means that the analytics that is analyzed of all the sorts of data is done more efficiently because it's all in one place. Secondly, with cloud computing, the cloud computing is able to scale the data much quicker. What do I mean by this? I mean that if for any reason the amount of data that reaches the database is way more than usual, this will not be a problem. Your system will not crash because cloud computing will automatically scale to allow that extra storage of data or to allow that extra analysis of that data, even if the data is coming faster. So all the business needs are taken care by the cloud computing. And the company itself can actually do their business as normal. They don't need to focus on the managing the business needs that in terms of scaling the database, making sure there's enough storage, making sure that the data is processed in a timely manner, that the business does not need to worry about. It can just focus on their normal business processes. The other component is the Internet of Things. Internet of Things is usually derived from things like sensors. Today we have lots of sensors measuring and monitoring different types of information. I can think of one where in a building, for example, a building may have air conditioners and maybe currently the building is using lots of air conditioner and the cost of the air conditioning is extremely high. With the Internet of Things, the business can actually, via the sensors, understand what is the temperature in the room. So when the temperature goes up, right, higher to your 38, 40 degrees, then the AI software can actually tell the air conditioning or signal air conditioning that now the air conditioning needs to come on. And then when the room is very cool, then again, right, the sensors will send alerts to tell or to switch on the air conditioner. So in that way, there is an efficient use of the air conditioning, which means that the cost for air conditioning will drastically reduce. So these are the sorts of examples that Internet of Things can actually deliver and help in efficiently changing and helping decision-making without any human intervention. Another component is the autonomous robots. Now, autonomous robots come in two forms. One, in a software form. It's a robot, but it's actually in software form. And I can think of an example back when I first started working as an analyst. I was an advanced statistician, but I was the only analyst. So I needed to do the projects end to end. In other words, I needed to clean the data, analyze the data, and also provide the insights and the conclusions. And of course, the cleaning of the data took 75% of my time. And it's not only about the time, it was also monotonous and boring. And I didn't quite like that role. And so I asked my IT to sit with me, understand the processes that I go through systematically to clean the data, and then to test that application that he made for me. And the result was that while it took me 3 weeks, now this is back in 2005, it took me 3 weeks to clean the data, and in the last week, I analyzed the data and had a solution. So now with the application, it takes me just 1 or 2 minutes to clean the data, which means that the organization had gained, right? We could do 4 projects in 1 month instead of 1 project in 1 month. And this is a large amount of money, because 1 project in those days was $100,000, $200,000. So it's a massive saving for the organization. So in that way, the robots are able to help me do my work more efficiently, but at the same time, increase the revenue for the organization. I'll just give you another example, because I mentioned that there are 2 types of robots. The other one actually looks like, in most cases, it's a hardware structure, and sometimes even looks human. I know in situations even here in Singapore, in the surgery room, when you have to prepare the tables for the next surgery, what actually happens is there's a robot that actually lays out the table with all the tools, the scissors and all the items that are required for the operation. And that's done in an efficient manner. I also know in some hotels where they have to do the housekeeping, and the task is to top up with the toothpaste, the shampoo, and the soaps. And that's done with robots, where they physically are able to, without any human intervention, even open the door, go in, and top up the items as required. So this is the world in which we are living in. And how does this all work? So if you're in the hotel, you find that there are different operations, right? Different services that are being provided using big data analytics. But that's not good enough. What we have to do is actually combine all our solutions, combine all our results, so that we even have more information by which we can continue to improve our models. So the results of other models actually contribute as inputs to other models that we want to make decisions about. And that is our AI, artificial intelligence. Artificial intelligence allows us to integrate all our systems into one system, whereby we are able to understand patterns from other business operations and incorporate that into our models. So that is my idea of Industry 4.0, right? The main goal is to work more efficiently, using our data smartly to make decisions at the right time, at the right place. If we look at now, how does data science relate to Industry 4.0? What is the difference? Okay, so we saw earlier on my slide that Industry 4.0 is where we collect the data, we investigate, we have different business cases. We may want to improve production capacity. At the same time, we're improving our safety and improving our operational continuity, so that we have the 360-degree view of all our products, all our services, all our customers. That is Industry 4.0, putting it all together, right? And at the same time, getting these analytical results and insights. What is data science? Data science is when you have a business problem or you have a business question. Data science comes in, where we take this data and apply scientific methods. We apply science to answer the question that the business has. So there is a difference between data science and Industry 4.0. And there is a difference between artificial intelligence and data science, right? Typically, most will know the understanding of data science as a combination of mathematical techniques, statistical techniques, and computer science. That's just part of it. I would say that there's still soft skills that are also required for data science, which is your communication skills. How do you present? How are you able to communicate the analytical results that are sometimes really abstract to your senior management or to a non-statistician? That is critical for data science. Now, let me maybe take you through the framework on how we analyze any project. How do we answer any project where there's a business question to be answered? I call this the data science framework. where we need to start with the problem. We should never take data and say, let's see what insights we can find, because then we will be, doing analysis paralysis. When you have a problem, that's when you get focused and you're able to actually take the relevant data that will help you to solve the problem. Once we have the relevant data, we then want to understand and explore that data, find the patterns in that data. And we do that through data visualization, and sometimes just summary stats, finding the means, medians, and modes of different products or of different customers. And actually, before we even start the modeling, we will have a good idea of which of the factors are really and truly contributing to answering our question. I will try and run you quickly through an example just to put this data science framework in context. Say, for example, you're a bank, right? And you have lots of customers coming to you for credit. And as a bank, you notice that a high percentage of your customers who you give credit to are actually defaulting. So this is a problem. So that may be the data science question from the bank. How can we, one, identify which customers will default? What is the probability of them defaulting? And what are the factors that allow us to understand which customers are going to default? Once we have those definitions and business questions, we would then take historical data, let's say of customers who came for credit for a 3-month credit loan. We'll look at that data. In that data, we need to have customers who have defaulted and some customers who have not defaulted. It's only then that we'll be able to understand the patterns of customers who do default. So in our exploration, typically what I do is I make sure to do most of our analysis of customers who default versus those who do not default. And I'll compare that in all my input variables. And that's the way I'll know which variables are actually contributing to identifying customers who default. Because the difference, there'll be a significant difference in the number of defaults for that variable if it's significant and contributing to identifying customers who default. So once I have that, I next want to understand which data to select. Now, data selection would mean that I only want the data that are important. I don't want, usually we have lots more data that we think are important, but are actually not important. So I'll do probably a significant testing and only include the significant variables into my model. So I may have 100 variables, but may only find 50 that are significant. Those are the ones I put into my model. I'll do some data preparation. What is that? That's typically also where I will introduce new variables. Dates are very powerful. If I have the date of when a customer started business with me, for example, I will compute based on today's date, how long has the customer been with the bank, and so on. In fact, when we generate new variables, that's the power in our model, because most people are already doing credit risk, right? And they're using the typical variables. But I think to have the upper edge on competition, it's really good to be innovative in new variable creation. Once we have all our data, of course, we would split the data into a training set and a validation set, because we will train the model, but we need to actually test the performance on the model using unseen data, which we call our validation model. And typically when we do our modeling, we also would make sure to build maybe 3 models, usually many more than 3 models, but we use more than one model, so at least we can compare models based on accuracies and domain insights, and then choose the best model. And once we've chosen the best model, we'll then validate on real data our best model, implement it to new customers, and then see, after maybe 5-6 months, we may look back and see, okay, of those that we gave credit to, how many of them defaulted? And by reviewing our models, we are able to actually improve our models, because we are able to see of those that defaulted, we can look into the data and better understand why did they default, yet according to our model, they're supposed to not default. And then we can actually update our model. We can tweak our model based on our findings and then run our model on the next batch of new customers or as they walk into the bank. And this is a massive amount of savings to the bank. One, the value of this model is that the bank can process whether a customer is going to default or not in 1 or 2 minutes, because the model will actually under 1 minute will give them the result as to whether the customer is going to default and the probability of them defaulting. Next, the bank will not need to have large number of queues of people waiting to ask for credit, because now it can even be done digitally as well to approve credit. So there's a lot of time also, and by having a lot of manpower in the bank to take the information down to approve credit can take really long, and still to tell the customer we'll be back to you on the result of your credit registration in 10 days time. So that's a lot of time. So you can count 11 days versus 1-2 minutes. It will definitely save the bank money and time. So next, I want to quickly look at another example on how does data science help businesses attract more consumers. So every business wants more consumers, right? More consumers means more money, right? And also helps the business to be sustainable. So remember I said we have to start with a goal. So in this case for consumers, the goal is to order and to deliver the right content to the right people on the right platform at the right time at the right price. And this business actually wants to know who buys the products, which media channels do they use to buy the products, and how do they buy the products, right? So these are the questions that the organization has. So firstly, to understand who buys the products, we have analytical techniques, firstly, such as market basket analysis. All it does is for each customer, it's able to see what they buy, right, in their basket. It's able to work out on average how many items do they buy, what's the value of the basket. It's then able to profile the customer based on what they buy. So if a customer buys oranges, apples, bananas, lettuce, onions, then we know, okay, this customer is a healthy customer. They buy fruit and vegetables. And what we are able to do in our back end of our application is actually to segment our customers based on the profile, based on what they buy. So this is our first step, understanding the consumer preferences. Next, once we understand your preferences, we want to move away from mass marketing, right? We want to promote the right product at the right time. So we need to do targeted advertising as well. And by targeted advertising, we are not spamming our customers with promotions of products that they do not want or are not interested in, because then the customer will get frustrated and leave. So with the targeted advertising, you are targeting with the right product at the right time, the right customer. We find that the customer experience is enhanced because they're finding the products that you're promoting are the ones they are interested in. And there are typical methods. You can use a simple multiple linear regression analysis or the marketing mix optimization model, which can actually analyze based on the amount of money you spend on advertising, whether it be to TV, through radio, through catalog, newspaper, etc. These models can actually work out which of those channels are effective, right? Effective in bringing in a sale. And if they're effective, what is the percentage of the return of investment for the business? So you may find out of the 5 channels that the company uses, only 3 channels are effective: catalog, radio, and online. Then the business knows that they can stop the TV, stop the newspaper advertising, and have more money for the channels that are bringing in the money. And then they can also see and compare the amount of return on investment each of those 3 channels that are effective bring in, and then understand if they need a last minute increase in ROI to meet their KPIs, they will know which channel to push that extra money in to meet their KPIs. So overall, it's also not about only attracting customers. I think it's just as important to retain customers. And many businesses don't concentrate on methods to retain customers, but there are techniques that can give insights as to which customers are about to leave a business and stop buying from that business. And that's your churn modeling, where we can do so, which is a supervised machine learning model that can identify the factors that contribute to churn. And also, like we did in our credit scoring model, we can have a churn modeling which can tell us, identify which customers are going to churn, the probability of them churning, and also the factors that are actually telling us or helping us to understand who's likely to churn. And then that same model that helps us to understand who's likely to churn can also tell us more information of which customers are staying and their high likelihood of staying, because it's just a reverse. And in that sense, the business can use that as well to understand which customers they would like to attract. In the future, they obviously want to attract customers that are likely to stay, that have a high probability of staying in our churn model. And so therefore, the data scientists can pass on that information to their sales and marketing to understand which customers to attract. Another use case is Netflix, right? So you're all familiar with Netflix. Netflix is simply the personalization of movie recommendations. And this is the era in which we're living in, right? There are so many movies to choose from. It will take us so long to maybe find a movie that we'll like. But with the personalization recommendation, it's so easy to just go on and Netflix will make recommendations to you. And it's simply based on what you have already watched or what you normally do watch, which types of movies you watch. And also it will look at your ratings of the movies and your reviews of the movies. So Netflix has this predictive technology, which looks at a combination of your choices of movies, how long you spend on watching movies, and it will look at people similar to you. And if there are movies that you have not watched, but the people similar to you have watched and enjoyed, then those are the movies that they'll recommend to you. So also Netflix also has the added capacity to see when's the peak time for watching movies. And using their technology, right, and using data science, they're able to work out when the streaming quality could go down because the peak time is way too many customers streaming movies. And then they know how to increase their bandwidth at certain times of the day. And based on the volume of users, they can also sometimes decrease their bandwidth. And in that way, manage the quality of their streaming as well as the costs for streaming from Netflix side. So we can see already how powerful data science is. And it's not only powerful, it helps you to make good decisions and it helps you to generate more money and save on costs. Another example that we are all quite familiar with is Siri, which is a virtual assistant. And I think more and more people are using it these days because it's so easy to just say, hey Siri, what's the weather today? Hey Siri, what are my appointments for this morning? And Siri is, of course, efficiently can do that for us today in this era that we're living. So Siri can not only help us answer all our questions. I would even tell you a short story of one of my friends who actually enjoys Siri. When she doesn't know what to do, she says, Siri, can you tell me what I can do today? Where I can go? I just feel like I need to go out. And Siri will tell her, I think Sentosa is a good day for you today. The weather is good. How about going to Sentosa Beach? And she'll go. And as she's going, she's actually talking to Siri. Siri is keeping her company on her journey to have let's say, a meal at Sentosa. And after that, she again says, okay, I finished eat. What else can you suggest? And Siri will tell her maybe to go and buy some items at Viva City. So the idea is that Siri not only answers questions, it can be valuable in many other ways. And in this case, keeping company for people. And also, of course, it's a learning tool as well. By asking a lot of questions, Siri can answer it. And in that way, we can learn a lot by using Siri. So next, I want to look at the types of projects that I am supervising. Capstone projects, which means real world projects, under the NUS MSc Industry 4.0. So this project that I'm currently supervising, the question is, what led to this project? Well, there is definitely a need for stock option investment decisions because you need the right timing, you need the right price, right? And in order to make money. And currently the client, as I said, it's a real world problem. The client does do buy wholesale, but in quite a manual way. Most of their program is more based on experience. But the client also knows that stock options are often mispriced. And if they are mispriced, there are opportunities to understand the stock option patterns and signals that allow them to do better trading decisions. And so my team, right, I have students that are working under me where the objective is to firstly understand the Bank Nifty index and option pricing patterns and relationships. Once they understand the patterns, they need to build a model that will derive operative trading signals, helping the company to understand when to buy and when to sell options on the Bank Nifty index. Once they understand the patterns and have built the model, they need to automate the derived insights and the signals so that the client is able to completely automatically make their trades, or at least see the buy signals and hold and sell signals, and then have a confirmation button once the human has looked at the buy options and then approve it and then execute it on the market. And that is very powerful because it does take a long time to analyze thousands of stocks, thousands of stock options. By the time you analyze it, the price is very different. So in that sense, this project will be very valuable for the clients. Another project is what led to this project is all about the rheumatoid arthritis. Firstly, rheumatoid arthritis is a disease that causes joint damage, and it's currently the scoring of this degree of joint damage in rheumatoid arthritis patients is done manually and actually quite subjective, right? So it takes a long time for the scores of the damage of the joints to be produced, because in some cases they need to, rheumatoid arthritis experts, a few of them need to come together before the final score is achieved. So this manual method is expensive because it takes a few experts to confirm the score. So with this project, we've developed an automated way to measure the degree of the joint space narrowing as well as the erosion. And it does it quickly and accurately. And another thing, it also does it consistently because there's no humans involved. We are able to look at from every angle. We are able to score the narrowing as well as the erosion. In fact, in some cases, we can see more than what the human eye can see, which means that the X-rays from the hands and feet are used more accurately for clinical diagnosis and research purposes. So the value of this project, so notice I'm always saying about the value of the project, because whenever you analyze any data, just knowing the accuracies is not good enough. There has to be a value, and it has to be meaningful for the client, right? Meaningful for the user. Your model, that's more critical than the accuracy of the model. So the value of this project is that it increases the speed and accuracy of joint damage scoring greatly, right? And so this helps healthcare industry in multiple ways. One, by having the automated scores, it can actually impact research studies. So maybe you want to understand which treatment is the best. For example, to understand which treatment is the best, we can have a clinical trial and we can observe the patients, let's say over 2 years, and maybe every month, this our application can score the patient's X-rays in 1 minute, and they can aggregate and on a longitudinal study and compare the results of the progress of the treatment for each of the patients. In other words, quickly understand, or at least at the end of the 2 years, understand which treatment is working, and if it's working, for which types of patients, because the patients may differ, of course, in terms of their stage of damage. So classification of hands and feet x-rays using deep learning technologies provide a standardized objective measure for joint erosion, joint narrowing, and joint damage. So this leads me to conclude my presentation. So I'd like to just also let you know that NUS MSc Industry 4.0 has also a degree program that focuses on Industry 4.0. And the beauty of this program is that it's multidisciplinary, and you can do it by coursework across 6 academic units. So the academic units could be, the Faculty of Science, Department of Mathematics, your faculty, or School of Computing, School of Business, and so on. So besides having 6 academic units that you can choose your modules from, it's also very flexible, because you can enter the degree program, right, at different points across different disciplines. And you can also do the degree part-time or full-time. And once you have the degree, of course, there are a large number of options for you for your career, right? The sky is the limit, in fact. This is just a sample of the different types of jobs that you can get once you have the MSc Industry 4.0. You can be a data scientist, robotic engineer, and so on. So if you're interested in the NUS MSc Industry 4.0 Master's Degree Program, the next admissions intake is in August 2021, and it actually opens now until the 15th of March 2021. So that concludes my presentation to you. Over to you, Terence.
Well, Professor Hargreaves, again, thank you so much. It is very insightful, and I do agree with you. For people who are keen to know more about data science and of the Master of Science in Industry 4.0 program, the sky is truly the limit. Now, ladies and gentlemen, we've now come to the segment where you decide what we are going to talk about, and that is through the questions and answers segment. If you have a question for us but haven't asked it yet, don't hold back any longer and fire away on the comments section. The NUS team will still be monitoring the comments section for new questions. So if you ask the question already, we will do our best to answer it. And as I was saying earlier, I think we've had a couple more questions come in towards the tail end of Professor Hargreaves' masterclass presentation. Now, joining Professor Hargreaves in answering your queries today is Miss Adeline Chi, Assistant Manager of Admissions and Graduate Programs at the NUS School of Continuing and Lifelong Education. Professor Hargreaves will be here to answer your queries on data science and her masterclass, while Ms. Chi will handle queries on admissions matters relating to the MSc in Industry 4.0 degree program. Ladies, thank you so much for joining us today. Team, let's have the first question up on screen, please. What is the difference between a data analyst and a data scientist?
A data analyst is someone who would do data visualizations, who would analyze the data. Typically, they will just provide insights. Data analysts, the types of skills, especially for programming, is not as wide and as broad. A data analyst will typically sometimes only use Excel or use one statistical software. For the data scientist, it's much more. Firstly, it's going to have to start with a business problem. Secondly, for a data scientist, you would need a combination of skills, whereas a data scientist is actually expected to be able to program. They would need to be able to use Python to come up with solutions. Then they will do the data analyst role. They will definitely analyze and find insights. They will build the models like the analyst. They have to solve the problem. So they have to make the recommendations, and they also need to demonstrate the value or the impact of this solution.
Okay, thank you, Professor Hargreaves, for that answer. For those of you who are tuning in, this question was submitted by Chiwi. So Chiwi, we hope that this the response from Professor Hargreaves has given you a better understanding of the difference between these two job roles. If you have a follow-up question, you can still answer them. Just fire away in the question and answer segment. And before I go on to the next question, I would just like to take this opportunity to remind all of you to leave your questions in the question and answer segment rather than the comment section, because we are monitoring the questions and answers segment. We noticed that there have been a few questions in the comment section, and while we are able to pluck out the few that we've seen so far, we may miss out some of your questions if it's in there instead of the Q&A segment. So please leave your questions in the question and answer segment. Now, thank you, Prof. Hargreaves, for the response to the first question. Could we have the second question, please? Okay, the second question reads, is there a course where I can learn enough of data science and yet or rather I can learn enough of data science to lead and manage successful and effective change or transformation in a gig economy organization, whether or not I'm part of senior management or I guess at the executive level. Professor Hargreaves?
Yes, certainly. There are courses for senior management. Usually these courses would be, I would guess, more in a 2-3 day type of short course. Because the understanding is that the senior management sometimes just wants to know, as said in the question, just able to lead successfully, data science within, I think it's big, right, organization. So these courses will actually not teach you the technical steps on how to build an algorithm, but they will focus on the outputs and how senior management can evaluate also the outputs in terms of, what are the insights and whether those insights will help the company. So these types of courses for senior management help them to gauge which models are providing domain insights for their decision making. I would say that they also help management also in terms of how to set up a data science team and what's important for a data science team to work effectively. And usually it's for a data science team to work effectively, it actually also starts off with senior management, right? When there's a buy-in, it's more likely to be successful. 2, we say that the culture also helps in whether data science will be effective. When we say culture, for example, just to give you a quick understanding, some organizations don't like failures, for example. But in a data science orientation, we are expected to experiment quite a bit because we're trying to get innovative solutions. And so some of our experiments may fail. So within organizations that want to grow within the data science, then they should have that culture to understand that, yes, we can experiment, fail quickly and up and running onto the next new creative solution. So it's about understanding the culture of data science, the experimentation about it in order to get creative, innovative solutions. And then lastly, in terms of senior management, we also guide them in understanding that it's not only about the getting talent that are analytically disciplined, but also when choosing talent, you need to choose talent that also has the soft skills. Because in data science, you need teamwork. You also need the data scientists to present the solutions in a data storing way. And then you also need the data scientists to be able to even build slides that are non-technical for senior management.
Okay. Well, thank you, Professor Hargreaves. I missed out the first part of this question earlier. I'm going to bring it out because I think it might add a bit of context, and also I think Professor Hargreaves, you might be able to shed a little bit more light as well. This question in its entirety came from Kang Swon Tae. I hope I didn't butcher your name, and I hope I got it right. Kang Swon was asking, Professor Carol, that he or she does not think that they are in a position to learn the nitty-gritty of data science like an accountant before leading on to the question of whether or not there is an exact course or an exact curriculum that would fit what they plan to achieve in the role of the gig economy organization. But the reason why I wanted to put this forward to you, Professor Hargreaves, is because I understand that you kind of stumbled into data science and statistics as well all those years back, right? You're like you weren't exactly maybe planning for it, but you kind of came across it, and I guess you thrived in it. So is there any advice you give to people who might be in the same shoes as you all those years back?
Okay, yes, actually I did stumble into it. When I first studied, I knew I wanted to do science, so I did maths, physics, chemistry, and so on. But I needed a filler, and I just took statistics. And I actually I got an A without much learning, where I had to pay a lot more attention to maths. So I did stumble upon statistics. But at the same time, I actually had a very inquiring mind. I was really curious. And of course, for me, I was fortunate that my lecturer was someone who, when he taught, he always asked a lot of questions and left it for us to solve. In fact, he also gave us a lot of homework, sort of. And I was that conscientious student who would always go and do my homework. And of course, the lecturer, whether it was conscious or not, there were always gaps in his scenarios. And so I was determined to get the solution. I would actually go knock on his door and tell him and explain my solution, and ask questions. He would give me information, just enough so that I can move on with the solution. And so in that sense, he didn't just give me the answer. And from that day on, how I learned statistics, how I learned data science, I actually also try to do that the same way in the classroom today. I like to ask questions and get the students to answer. I don't like to give them all the information. I find the learning comes out because their solutions or their answers are quite creative as well. And instead of just hearing one answer, mine, they can hear a few answers and see that data science also, there is no model solution, which many people cannot get their heads around. There are many solutions and they could all be right. It all depends on, where you want to focus, how you clean the data, how you prepare the data. And so the insights at the end of the modeling may be quite different and unique. And that's what we like about it. We don't want all the solutions to be the same. No, it's the opposite. We like to actually see the different solutions from different models and then say, okay, which model we want to go for. And then sometimes model A is more preferred for a certain profile of customers, while model B is absolutely correct for another profile of customers. So yes, I did stumble on becoming a data scientist, but I would say that many people do statistics. So it comes with also the curious mind. For data science to be a good data scientist, you need to ask a lot of questions and continuously, even when you have your results, to continuously ask questions. And in that way, you're always improving your solutions, always moving on to new solutions. Data science is something that if you want to be a data scientist, you have to be learning all the time. It's continuous learning because new technology is coming in all the time. And so people might think machine learning is new. No, for me, it's a given, right? Machine learning is not new. We have to be doing generative adversarial networks, autoencoders, much more newer technology to solve the solutions of today.
Okay. Great answer, Professor Hargreaves. Kang Swan, I hope this kind of sheds a bit of light. Shed a bit of light as to what you were looking for. I think it kind of nails it there. That the important thing to have is a curious mind, like what Professor Hargreaves has mentioned. You could take any course you want, but if you don't have the curious mind to want to get to the bottom of a problem, you might not succeed as much as you should. So hopefully you take note of that. Okay, thank you, Professor Hargreaves. Can we have the next question, please? Laura would like to check on the prerequisites to admissions to the Master of Science in Industry 4.0. She would like to know if she could apply for the Master of Science in Industry 4.0 this semester, and if not, could we share with her, what are her options at this point in time?
Yes, you can apply. Okay, you have a bachelor's degree, even though it's not in the field of science, engineering, analytics, but you are taking a certificate in foundations in computing. So that will definitely be taken into consideration. Of course, just obtaining the certificate is not everything. We will also look at the GPA you have attained. So yes, please submit your application so that we can review it.
Okay, one of the prerequisites for the Master of Science in Industry 4.0 program is to have a basic knowledge of programming. How do we assess this?
So basically, if you have done programming courses, you can actually submit certification to us. And if you do not have any certification and during your undergraduate studies, you did not take any course on programming as well, then you will be recommended to complete at least 1 or 2 courses online. So after completion, you will be asked to provide the certificate to us.
What are the advantages of a multidisciplinary program like the MSc in Industry 4.0 as compared to other more specific and specialized programs?
So multidisciplinary, of course, then you just have a much bigger choice because these same programs, these same master's programs, you can choose your modules from. So it just gives you more flexibility.
Okay, just to add on to what Professor Hargreaves has mentioned, I think the advantage of a multidisciplinary program, kind of highlighting what Professor Hargreaves mentioned earlier, is that you really get to learn more. I mean, sure, you some people may argue you may not learn something specific, as in you may not learn something as in depth in a multidisciplinary program as, say, compared to, say, a specialized master's program. But the flip side to that, or rather the other side of the coin to this, is that you get so many more skills that make you so much more, potentially more viable to other people out there. So it's a personal choice, and I do agree with Professor Hargreaves that you need to look at the options that you have on the table and then make the choice for yourself. But in a nutshell, hopefully these the pointers that we had both just shared would go on to help attendees out there have a better idea of what's the best step that they should take next for their future. Thank you, Professor Hargreaves. Next question, please. I think this question might be for Adeline. For the part-time program in the Master of Science in Industry 4.0, what is the duration of the Capstone project? I would assume a follow-up question to this too. Professor Hargreaves, if you have anything to chip in, you can chip in as well. I would assume the follow-up part to this question is, would there be a difference in the duration of a Capstone project between a part-time program and a full-time program?
Okay, there is no difference between a part-time and a full-time capstone project. Okay, basically the total duration of this project is about 5 months.
Okay, Ken. So for to the attendee who asked this question, there you have it. Professor Hargreaves, can I just ask a follow-up question to you on this? For the capstone projects that you have supervised so far, what's it like, in a day of a capstone project member?
Okay, so firstly, for sure, there will be team work, and a typical data scientist needs to get familiar working with a team and learning how to manage a team, because there are different personalities in the team as well. Second, you need to be able to manage your time, because it's a real world project. So you need to structure your capstone project like a real business project. You need to have your milestones. You need to, at the start of your capstone project, understand the different tasks that need to be undertaken in order to deliver the different milestones on time. Then you would also be working with a real client, a real business person. So therein lies the challenge that while you are developing models that are highly, sometimes statistical, the client will not understand it. So you have that challenge to translate your model outputs and insights in a way that the client can understand it. So sometimes you even have to build a software tool, a small application, be it a Flask application or Dash application, so that you can actually show the customer, this is how my solution will work. Sometimes, of course, dashboards help as well. So my main point is that the model itself, that's not what they're interested in. It's more as how they can use your model, what are the insights that come from your model, as well as whether those insights, right, make business sense, whether that model can drive either money or more customers or help them to work more efficiently. So what they are looking for is something very business-like, and they want a solution that adds value. So typically the normal student projects or assignments are more focused on the accuracies of the model. That is not so important, because in any case, most times those models are overfitted and unrealistic. So when working with the client, you have to balance the importance of accuracy and, in fact, more weight to the value and impact of your solution to the clients. So it is a bit more in terms of harder work, because you actually have to do, while your master's capstone project is an academic project, so we expect you to still build the models and have accurate models and show us which models you did. We need to know that it was accurate. At the same time, we also need to deliver more on your softer skills, a solution. And even when you do your presentation, it needs to be balanced. We're not so interested too much in the model formulation, and you need to be able to do a presentation that is a data storing one that still shows clearly the insights and the value of your project.
Okay, Ken. Thank you, Professor Hargreaves. Could we have the next question, please? And in the meantime, while the next question is coming up, to the individual who asked that question earlier about the duration of the Capstone project, I hope all the responses here have given you a better understanding on not just the duration and how long it will take, but also what goes on in the day of being in the Capstone project team and the things that you need to take note of when you are working on a Capstone project. Now, we have the next question on screen right now. For professionals in different fields, what would one's advice be for self-studying data science and analytics, I would believe?
Firstly, you would have to start with some sort of programming knowledge. So there are some good programming, data camp, for example. You get a few online courses that can help you at least to get started in your programming knowledge, because when you go for the course, it's an expectation that you can already do programming. Second, I would always do the data science study in a way that, you got to ask questions. Don't be shy to ask questions, because that's where the learning takes place. Most of the information will never just come from one source. Even when you're in a certain program, you always have to venture out and gather a lot more information to improve capabilities. I would also say that, again, working teams as well, definitely different solutions, different ideas come at play. And so that your solution that you put through, it's been well thought of because it's been debated within your team, discussed, and I would say more innovative solutions or more accurate solutions can come out.
Okay. Thank you, Professor Hargreaves. I think we have time for just 2 more questions. We have a lot of questions today, and just to let you guys know, for those questions that we are unable to tackle on air today, my colleagues will be reaching out to you guys to give you a response to the question and then engage you guys further. So do not despair if the last 2 questions are not the questions that you had asked. My colleagues will be reaching out to you in the next few days or so. Okay, team, let's have the second last question. Hello, that's also the question asked. Any subsidies for Singaporeans and what's the cost of study? Thanks. Well, I think what this individual means to ask is what are the subsidies like for the courses that I guess we are talking about? And I guess for today, we're talking about the Master of Science in Industry 4.0. Adeline, could we get you to chime in on this?
Yeah, okay, so for Singapore citizens and Singapore PRs, you are eligible to receive up to 70% subsidy for the elective modules. Okay, for Singaporeans that are above age 40, the subsidy may be up to 90%. Yeah, so that is the subsidies that's available for our Singaporeans.
Okay, great. Thanks, Adeline. Team, can we have the last question for the day? What is the intake size for the upcoming 2021 batch of students in the Master of Science in Industry 4.0?
Okay, for August 2021, we are looking at taking in 100 students. That will be the intake size.
Okay, great. Ken, thanks a lot, Adeline. And thanks again, Professor Hargreaves. We've come to the end of today's masterclass, and unfortunately, we are unable to tackle all the questions that we received so far, but fret not. For those questions that have come in but were unable to be featured on air, my colleagues would be reaching out to you guys separately over the course of the next few days or a couple of weeks or so to just share our thoughts and responses to your questions and engage you further on that. But moving on behalf of the faculty team leading the NUS Master of Science in Industry 4.0 graduate degree program, we sincerely hope that you've enjoyed the session today and learned something new today. I would like to think that my promise earlier today of how this is going to be an insightful and exciting ride has panned out. Don't fret, like I mentioned, if you weren't able to have your questions answered, or if you have a question that is only coming up now, if you haven't had a chance to answer your question, get in touch with us. Our email address is pgc@nus.edu.sg. If you see it if you look at the bottom right corner of the screen right now, you will see the email address in blue text. I repeat again, our email address is pgc@nus.edu.sg. That's Papa Golf Charlie @nus.edu.sg. If you have a question about the Master of Science in Industry 4.0 graduate degree program, also get in touch with us via the same email address. And that just about does it for me and the NUS team right now. Thank you once again for spending some of your Saturday with us. Before I go, I just want to leave you with something to think about. For those of you who are interested in the Master of Science in Industry 4.0 graduate degree program, the closing date for applications are 15th of March 2021. So I know we still got a bit of time, and if you're interested to find out more, hit us up via email and we'll get back to you and share as much information as we can to help you make an informed decision for a better future. But until then, don't forget to mask up, maintain a safe distance from others while you're out of your home, and don't forget, most importantly, to stay cool and keep your chin up for 2021. We will get through this pandemic together, and I promise you our futures will all be better. Have a great weekend, you all. Goodbye.